My name is Vaishni. I am from SRIT College. Now I am going to present about types of operators in C. Operators. It has a symbol used to represent some operations or computations. Operators are special symbols or keywords used in programming languages like C, C++, Java, Python, etc. to perform specific operations on data. They take one or more operands and produce a result. Example, a plus b. Here plus is an operator and a and b are operands. Classifications of operators: unary operator, binary operator, ternary operator. Unary operators. These operators perform an operation on only one operand. Binary operators. These operators perform an operation on two operands. Ternary operators. These operators perform an operation on three operands. Types of operators in C: arithmetic operators, relational operators, logical operators, assignment operators, increment and decrement operators, conditional operator, bitwise operators, special operators. Now we are going to see about arithmetic operators. Arithmetic operators. These operators are used to perform mathematical arithmetic operations like addition, subtraction, multiplication, division, and modulo division. These are the binary operators, hence requires two operands to perform operation. Operator plus it is the symbol. The meaning of the symbol is addition. It returns sum. Example, 12 plus 2 is equals to 14. Minus, the meaning of the symbol is subtraction. It returns difference between two operands. 12 minus 2 is equals to 10. Multiplication, asterisk symbol denotes multiplication. It returns product. 12 into 2 gives 24. Slash forward slash gives the meaning of the forward slash is division. It returns quotient. Example, 12 by 2 is equals to 6 percent. It is the symbol of modulo division. It returns remainder. 12% 2 is equals to 0. Relational operators. These operators are used to compare two operands or data items or expressions and given relation between them. Hence, they are also called as comparison operators. These are binary operators. The result of relational expression is always a Boolean value, that is either true or false. If the relation is true, it returns 1. If the relation is false, it returns 0. Greater than, example, 21 is greater than 22. It was false, so it returns 0. 22 is greater than 21. It was true, so it returns 1. Greater than or equals to, 22 is greater than or equals to 22. It was true, so it returns 1. 22 is greater than or equals to 21. It was true, so it returns 1. Less than symbol. 21 is less than 22. It was true, so it returns 1. 22 is less than 21. It was false, so it returns 0. Less than or equals to, 21 is less than or equals to 22. So it was true, so it returns 1. 21 is less than or equals to 21. It was true, so it returns 1. Equals to, 21 equals to 21. It was true, so it returns 1. 21 is equals to 22. It was not true, it was false, so it returns 0. Not equals to, 21 is not equals to 21. 21 is not equals to 22, so it returns so it was true, so it returns 1. 22 is not equals to 22. It was false, so it returns 0. Logical operators. These operators are used to know the logical relationship between two Boolean expressions. The result of these operators is also a Boolean value, that is either 1 or true, 1 true or false 0. These operators must be applied between two Boolean values. These are the operators of Boolean value. These are the Boolean operators and logical and. Example, 28 is greater than 8 and 30 is less than 48. It was true. Logical odd. 15 is greater than 28. it was false, or 35 is less than 65, it was true. So it returns 1, true. Logical note: 56 equals to 56 is not, it was no, it is the symbol of a not, so it returns a false because it is the assignment operators. These operators are used to assign or store some value, the result of an expression, to a variable. It is a binary operator, requires two operands on either side of equals to. Example: sum is equals to 10. The value of 10 is assigned to the sum. Sum is equals to 25 plus 45. The result of expression 25 plus 45 is assigned to the sum. Sum is equals to sum plus remainder, is also written as sum plus equals to remainder. Now we are going to talk about increment and decrement operators. C supports two powerful operators called increment and decrement operators, used to increase or decrease the values of its operand by 1 respectively. It denotes as plus plus and minus minus. These are unary operators. The operators plus plus adds 1 to its operand. The operators minus minus subtracts 1 from its operand. Consider an operand m. Increment of m is denoted as m plus plus. Decrement of m is denoted as m minus minus. Increment or decrement operators are in two different forms: pre-increment or post-increment, denoted as minus plus plus m or m plus plus. Pre-decrement or post-decrement, denoted as minus m or m minus minus. Pre-increment or pre-decrement, increment or decrement the value of first by 1, later it assigned it to the operands. Example: m is equals to y is equals to plus plus m. The value of m is 6, y is equals to 6. Post increment or post decrement, assign the value first, later it is decremented by 1. They are incremented or decremented by 1. Example: m is equals to 5, y is equals to m plus plus. The value of m is equals to 6 and the value of y is equals to 5. Conditional operators. The ternary operator pair is known as conditional operator. It is called ternary since it requires 3 operands to perform an operation. It is similar to its if statement in C. Syntax of a conditional operator is expression 1 question mark, expression 2, expression 3. Here expression 1 is in Boolean condition. Expression 2, statement to be executed when the condition is true. Expression 3, statement to be executed when the condition is false. Example of conditional operators: max is equals to a is greater than b, question mark, a, b. Value of a and b were compared. If a is greater than b, then max is equals to a, otherwise max is equals to b. Bitwise operators. These operators perform manipulation of on bits rather than numbers. Hence, they are also called as manipulation operators. It is the symbol of right shift 25, right shift 3, left shift 25, left shift 3. Bitwise and 8 and 18 and 5. Bitwise or 18 or 5. Bitwise not 25 not 25. Bitwise XOR exclusive or 85 5. Right shift. If the bit of a given number are shifted towards right side, then it is called right shifting, and the resultant value is called right shifted value. Example: suppose x is equals to 15 and it should be shifted towards right for one time, then it is indicated as x right shift 1. If x is equals to 15, then x right shift 1 gives 7. Shortcut to find right shifted value formula: right shifted value is equals to n by 2s. Here n is given number, s is number of times to be shifted. Example, suppose n is equals to 15 and s is equals to 2, then right shifted value is 15 by 21, that is 2 into 1, that is equals to 15 by 2, that is equals to 7. Left shift: if the bit of a given number are shifted towards left side, then it is called as left shifting and the resultant value is called left shifted value. Example, suppose x is equals to 15 and it should be shifted towards left for one time, then it is indicated as x left shift 1. If x is equals to 15, then x left shift 1 gives 30. Shortcut to find left shifted value formula is left shifted value is equals to n into 2s. Here n is given number, s is number of times to be shifted. Example, n is equals to 15 and s is equals to 2. Left shifted value 15 into 2 into 1 is equals to 15 into 2, that is equals to 20. Bitwise AND operator: these operators perform ANDing of corresponding bits in two binary numbers. This is bitwise AND table. Both are 0, it gives 0. If one is 0 and another one is 1, it gives 0. One is 1 and another one is 0, it gives 0. If both are 1, it gives 1. Example, m is equals to 28 and n is equals to 15. In binary form, m is equals to 28, 1 1 1 0 0. In binary form 15, 0 1 1 1 1. By comparing both, we get 1 0 is 0, 1 1 is 1, 1 1 is 1, 0 1 is 0, 0 1 is 0. Total is 12. Bitwise OR: these operators perform ORing of corresponding bits in two binary numbers. Bitwise OR table: if both are 0, it gives 0. If one is 0 and another is 1 is 1, it gives 1. One is 1 and another one is 0, it gives 1. If both are 1, it gives 1. Example, consider m is equals to 28 and n is equals to 15. Then m or n is equals to 31. M is equals to 28, n is equals to 15. M or n, it gives 31. Bitwise OR XOR: this operator perform XORing of corresponding bits in two binary numbers. This is a bitwise XOR table. If both are 0, it returns 0. One is 0 and another one is 1, it returns 1. One is 0, one is 1 and another one is 0, it returns 1. If both are 1, it returns 0. M is equals to 28 and n is equals to 15, then m XOR n is equals to 19. In this form, m is equal, binary form of 28 is 1 1 1 0 0, binary form of 15 is 0 1 1 1 1, and by that we get 1 0 0 1 1. It is the binary form of 19. Bitwise NOT: this operator perform negation of bits in a binary number. Bitwise NOT table: if it is 0, it returns 1. If it is 1, it returns 0. Consider m is equals to 28, then m is 3. M is binary form of 28 is 1 1 1 0 0. By using NOT, we get 0 0 0 1 1. It is the binary form of 3. Special operators: C supports 3 special operators: comma, size of, and address operators. Comma operator: this operator is used as a separator to separate variable elements, etc. It is denoted by comma. Example, int a comma b comma c. Size of operator. This operator returns the size of a given data type like variable, array, pointer, structure union at any point of time in terms of bytes. Syntax. Size of data type. Example, m is equals to size of int. It gives m is equals to 2. The size of m is equals to 2. Float num comma m is equals to size of num. It gives m is equals to 4. Address operator. This operator returns the memory address of a given variable. Once a variable is declared, sufficient memory gets allocated to the variable. Such each memory location is identified by a unique memory address. To know the address of a variable, the address operator will be used. It is denoted by AND symbol. It returns an unsigned integer value. Syntax and variables slash name. Example, int name address of num is represented as address of num.